start. Thank you. I want to thank Linda for that awesome talk, and the reason why I wanted to talk about Tolly, especially later on, is the essential of freedom of communication and so forth, and that's exactly what we're working on at Microsoft of all places. Who would have guessed? So, anyways, let's get started here. I am not going to be Mark Zuckerberg, never will be, thankfully. Instead, we are going to be talking about the mother of all monad demos, and so I have the wonderful Bodil to be helping me do this one, and it's going to be in the style of The Mother of All Demos by Douglas Engelbart. Because, I mean, right now, a monad is just a monoid in the category of endofunctors. And if you don't get that, I don't know how I can help you. No, but seriously, this is not going to be a monad tutorial. In fact, that I find most monad tutorials brain damaging and not entirely very useful. So here's what I'm actually going to be talking about: is I don't work for Netflix, but I have an experience working with them. They have some very, very large problems that they needed to solve, and they were having a really hard time to do them in the language that they use the most, which is JavaScript. If you want to follow along at home, I have the slides and all the resources available there. But I didn't really like the title, Async JavaScript Netflix. No. You have to go more grandiose than that. You have to say how I stopped worrying about asynchronous programming and learned to love the observable. Or we can do an alternate, which is always good, is I thought I had a problem, so I thought to myself, I know, I'll solve it with promises and events. Have now problems to I. Yes. All right, concurrency jokes. They never get old, like I said. So as I said earlier, I am Matthew Podwysocki, for your Americans in there, Matthew Podwysocki. And I work at a company, which I will get to later. You can find me here, and I'll talk about the Tolly project just a little bit later. But I'm hoping in the next year or so, people will start to hear about that in the JavaScript circles. So as aforementioned, I do come from this small company here, but I do think that I put a little bit more metal into it. You know, especially Norway being awesome with metal, I just had to do it. So, anyways, we came out with this Edge thing, but I don't think it was inspired by him. I think it was really me. I could be wrong. But I was really bad at making songs, and I realized it's JavaScript's fault. Okay, nobody gets IEEE 754. All right. Thank you, Brendan Ike. Anyways, so what we're here really to talk about, and sorry, Suze, the electric eel is already taken, is the reactive extensions, and that's something I've been working on and off since 2010. And we have our own site, ReactiveX.io, and at ReactiveX on Twitter. And I am, in fact, an Rx pusher. So whenever I get a chance to, yes, I like to find new directions to push it into. So Netflix, let's get to where we are with them. Their whole mission is that they want to stream movies and shows to every single device possible that has a screen, obviously. And so what they account for is 1/3 of U.S. broadband traffic. I mean, this is dated information. It could be half, 3/4 by now. Who knows? But they had some really big problems along the way. And the really big problems were ultimately solved by thinking slightly differently about how they thought about events. So everything about the Netflix app that you use today, if you use it, is asynchronous. Everything. The app startup, the player, the data access itself, animations, view models, and bindings, and so forth, completely asynchronous. How do you handle all of that mess? It gets very, very touchy very quickly. And it causes any number of problems, especially if you're using the very traditional things that we're used to, such as callbacks and events and even promises. So it would lead to things like memory leaks, race conditions, callback hell, very complex state machines, and very disjointed error handling where you weren't quite sure where the error was really thrown. You're just looking through stack traces and doing caveman debugging via console.log. So going back a few years, what Netflix really had a problem with is they had 30 some odd developers, but each of them were using a different language for a different platform. So they would have a Java core team, they would have a .NET team, they would have some that were working in Clojure, someone working in JavaScript, but they all had very, very different ways about thinking about asynchronous programming. Of course, Java has its own way of thinking about it with futures and so forth, and it's really gnarly when you have all these anonymous inner classes. And with Clojure, they have their own style, and with .NET, they have their own style, and JavaScript has 20,000 different styles about talking about it. So what they did going forward is they actually standardize on the reactive extensions. And what it is it's a language-neutral platform for kind of creating these ideas where everyone can switch between, I can be a Java developer one day and I can be a .NET developer the next, but I speak the same language because I understand the same paradigms. And, quite honestly, in the world that we're living in right now, is that real-time data is absolutely everywhere. With our phones, everything that we deal with is really kind of intense, because what we're seeing is that it's so easy to get overwhelmed. We have GPS data, we have Twitter data, we have Facebook data, any number of things, and then at a certain point, you can't help but just give up and just start shoving things down your shirt because you just can't possibly keep up with it. But the problem has always been that asynchronous programming is just plain awful. Because we all have different ways about talking about it, whether it's promises, whether it's callbacks, whether it's events, whether it's streams, and you just end up not being able to balance it all and not coordinate. Obviously, coordination is this guy's major issue here, I think, or just being an idiot, one or the other. So we had a fairly forward-looking president back in the 1960s, and he said, we choose to solve asynchronous programming and other things, not because they are easy, but because they are hard. But this is only a first draft because he realized asynchronous programming wasn't exactly possible within that decade. So he changed it to going to the moon. And now we're stuck with the fact that we still haven't solved asynchronous programming. Great. What's that? But we're on the moon, but we still can't fix async. I tell you, where are our priorities? I mean, callback hell is a real thing. And what I mean by that is not just you have nested callbacks, but it's more than that. It's more along the lines of you have this finite state machine where you have all of these loose variables sitting in around, where you kind of just have to kind of mold around there to see whether the players initialize them, check if they have a movie ticket, all of those sorts of things, and then have all of your errors just propagate all over the place. And so what you ended up with is a cow's head in terms of how the code is shaped. You go all the way down and all the way back. It's a very simple little thing, but it's so easy to get burned that to me, I just want to run away every time I run into that situation because it's really hard to find out what I'm supposed to be doing besides jumping out a window. And the same really goes for events as well, is the fact that, to do a simple thing like drag and drop, you have to have some sort of floating state, your state machine. You have to determine whether the mouse is down, move it, and then you have to resource management as well to prevent memory leaks and so forth. So you have add event listener and remove event listener. Great. Yep, once again, makes me want to run away. So once again, it's juggling all of this state that I don't find all that appealing. And I don't know about you, but I have that same horror on my face every time I see, someone doing add event listener. So, the fine folks at TC39 said, we have a solution for you. They're called promises, so we can say player initialize, then authorize movie, and login error, and then we can play the movie, or you have it unauthorized. That's great, isn't it? No. And the reason why it's not great is the fact that the promise that they standardized doesn't actually have a cancellation mechanism. So you're like, oh, I'm going to start typing. I want to cancel previous request. I can't. Well, shoot. What was the point? So it gets even worse because you have all of these requests that are going out that you just don't care about anymore. And there's no way to physically cancel them because they said it was too hard, so let's go shopping. So it got so bad, and it kind of came to a front when the HTML fetch API came out. I don't know how many people have actually used it. But as you can see, the goal was, how do we cancel a promise? And this was taken a little while ago, and and even still, there are 182 comments of how to cancel a promise. So I think it comes down to, there is a joke somewhere in there of how many engineers does it take to cancel a promise? I think. Anyways, so that's still an ongoing solution. They don't know. And I'm like, well, the answer has actually been in front of you for quite a while. And same thing with Bluebird is the fact that they had this cancellation, but it's a very, very awkward one. So they said, let's throw it away and let's redo it all over again. And they never even had a chance to do in ES 2015 the idea of finally. So you can't exactly say, well, at the very end, clean up my resource, do something. Well, I have success and error, but that's about it. So once again, you've got a nice car, you've got a nice gas pedal, you've got a nice cup holder, but no brakes. So unsafe at any speed. So anyone who then thinks, well, we've kind of solved some of the other problems through stream processing, especially when you think about streams, you think about, Node, obviously. And let's face it, they were awful. And so pause didn't. Data event started immediately, whether you liked it or not. And you can't just consume another bytes. It just shoved it all at you. And pause and resume weren't really all that easy to get right. I know some people who are active in streams will probably want to hurt me right now, but oh well. Then we came out with Streams 2, and still it was very easy to get tripped up because now we had 4 different subclasses for how to create streams, whether they were readable, writable, transform, or duplex. And then Streams 3, once again, still kind of a tangled mess in terms of trying to solve some of the other really hard async problems. It's really good for I/O, but other than that, not so much. So let's actually go back a little bit in time, probably before most of you all were born, because I'm an old geezer like that. So who here remembers 1994? Let's see. Wow, all right. So I am not as old as I think I am. Okay. So in 1994, there was this book that came out, and it was called Design Patterns, and it was by these 4 authors. Eric Gamma, who now works at Microsoft of all places, was one of the lead authors for this. And they, for the first time, codified this idea of design patterns for the first time. But they also created a number of relationships. And we looked at that back as part of the cloud programmability team that we were at the time and said, well, there was something missing here. And the fact that there was no real concrete connection between the iterator and the observer. And there should have been. Because on one hand, you're dealing with a pool-based collection with the iterator, and the other time with a subject-observer pattern, you're dealing with push-based collections. So with 2015, we do get, sure enough, we do get the iterator pattern, so we can call next, 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 next. And then as each time we do it, we get a value and whether it's done. And then when we're finally done, it tells us done is true. This is a lot better than the previous designs, which actually threw an exception when you were done because, well, Python. And so just as well, we are always used to the subject observer pattern because we use it every day in JavaScript. Anytime you say add event listener or on or anything like that in Node, you are exactly using the subject observer pattern. So anytime you move the mouse, sure enough, the client, you start getting data pushed at you. So let me ask you, if we can distill this just a little bit, what's the difference here between an array and an event? And really, I don't think there's any difference at all, other than the fact that one is push and one is pull. They're both collections. In fact, that mouse is a database. Anything that you can do with an array, you should be able to do with your mouse. Why not? That was our crazy dream, and it was a dream that kind of came out of a weird place in Microsoft because we didn't really like Silverlight all that much, hence why we were shut down. But anyways, what we were trying to do was take an application written in C# and to be able to cross-compile it to Silverlight, JavaScript, whatever. And we found that the problem was we couldn't marshal events. So, hence what we came up with the observable. Now, the majority of Netflix's code, and I'm going to show you some code examples that they've had along the way, can be solved pretty easily by just using the functions you're pretty much already used to when dealing with arrays. For example, map you're already familiar with in terms of arrays, where you take an item and you transform it to something else, such as taking a circle and turning it into a triangle. Same thing with filter. Now, merge all is slightly different, is the fact that they have array, concat, and so forth, but that really only just combines the two. What this does is really takes arrays of arrays and kind of smushes them together. But when we're dealing with asynchronous or collections over time, as I like to call the push-based, is the fact that they can be interleaved based upon when they actually happened. And flat map is kind of a way that what we can do is we can compose one with another observable or another array. And hopefully in the ES7 timeframe, flat map will actually be considered as part of the array as well. So that's my hope. We'll see if it actually happens. So in order to get the top-rated movies, what would you do? I'll just use ES6 because I don't like to type all that much. So for a given user, we can take the user's video list. We can map through each video list, get each video from all their video lists, and filter them where their rating is 5 and merge them all back together. Or instead of using that, we can just use flat map, and basically now what we have is we have all of a particular user's movie, and then based upon whether the rating is 5. And all we have to do at the very end is call for each, and we can display the movie. Pretty simple. Now, what if I told you taking this exact same piece of code on something that may be completely synchronous and taking it to something completely asynchronous? Would it be possible? And the answer is yes, absolutely. So, for example, we can take get element drags given an element, go mouse downs, map mouse move with the document, and then we can take instead of filter, we have take until, and then we merge it all, or just use flat map. So let's take a look at that. There. There is really not much difference at all. In fact, all we have to do is just remember that filter doesn't really do what we want it to do here, but take until does. So it's very, very similar in terms of the idea is that you can stop a particular stream just because you want to. And what we end up with is this idea that whereas Ghostbusters saying that crossing the streams are bad, we think that crossing the streams can be good. After all, it did save the world. And you come out with this Zen-like moment, as it were. Enough with cats. I can have more cats here too. But you end up with this very Zen-like moment where you're like, everything's a stream. My mouse is a stream. My keyboard is a stream. My screen is a stream. My phone is a stream. This is awesome. I can now query them the same way I would query an array. So now what we have now is this idea of a first-class asynchronous value, and not a promise, in the fact that I can now send it into a function and I can return it from a function. And you can construct them at runtime. You can do whatever. You basically have this notion of this event or this collection over time. So no more of these callbacks. Now you have this idea of this object of mouse moves. I can hand to you, and so forth. Now what's interesting is when we're talking about these kinds of things, we're talking about a different programming landscape. We're talking synchronous versus asynchronous, multiple value versus single value. For single value, synchronous, obviously, you can call a function or you get a value. For an array, you can filter and then filter and map and get the stock quotes. For a promise, you can call some asynchronous function and call then on it, and something will happen. And with observable, as you can see here, there is absolutely no code difference between observable and array here. Just the only difference is one is going to be blocking and the other one won't be. Now, this term reactive programming that everybody seems to be using. I mean, if you go on to NPM on any given day, you will find this new reactive library that's going to change your life. Yeah. And then, of course, you have React, and you have Reactive, and you have all of those other things that are just completely muddling the waters of what exactly reactive programming is. So let's go to the dictionary. The dictionary would tell us that it's readily responsive to a stimulus. Super helpful. So meaning its components are active and able to receive and process events. Great. But you really want to know where this term reactive programming came from. There was a paper back in 1987 called the Real-Time Programming Special Purpose or General Purpose Languages. Yes, that's a really long title, but you can get to it at bit.ly/reactive-paper. Yeah, I know it's a lot to ask of people to go ahead and read an academic paper, because this is what happens when most people see one, and sometimes me included, is the fact that we end up into this utter mush. And even one of our fine non-mere mortals, one of our immortals here, she even sometimes has problems with these kinds of papers. What's that? Oh, only small problem. Well, good to know. In fact, there is a German word for all of this, because, the Germans have words for just about everything. All completely one word, cram all words together. So you have Computerwissenschaft akademische Papierphobie. So the fear of computer science papers. So something like that. So when people talk about reactive programming, they immediately throw out this thing called functional reactive programming, which I don't think they understand what that means. But anyways, let's kind of clarify what that actually means. Functional reactive programming is a concept that came out of the late 90s with Connell Elliott and Paul Hudak, and it was really about how to do continuous time and to design systems based upon continuous time, where you could do animations and so forth. They came out with languages such as Fran and Active Vermal and so forth. So they have these behaviors, as you can see here, that you could model over time, and then events which were more discrete phenomena. that happen, but all throughout its continuous time. And most of all, it had to have denotational semantics. The denotational semantics saying exactly how each thing operated. No JavaScript library out there does that. None. Because it is impossible to look at any particular system that can use continuous time. Why? You would block the thread. That's why. So when people call it FRP, I would say, if you're not into the whole brevity thing, just call it compositional event processing. Don't care. Come up with a new name, but don't call it that. So let's actually talk about what's the anatomy and how do we create these things in the very beginning anyways. So for example, if we're taking an existing event and we want to turn it into an observable, as it were. Well, we can easily do that by calling create with a handler, so we can add an event listener. And the most important thing, and the thing that other systems lack, like CSP and so forth, is a very deterministic teardown. I can say create a disposable, and then when that disposable happens, meaning take until, take one, any number of those things, that event listener will be removed. So there is no time at all where you're going to have memory leaks unless you're doing something really silly. So let's actually take a look at some code where it makes the most sense. So for example, how many people have done kind of a type ahead or autocomplete or something like that and done it by hand? How many people got it right? Not that many, okay. So let's actually take a look on how exactly they did that, because it's a really hard problem. You're taking user input, you're throttling or debouncing it just a little bit because, time is money and bandwidth is money. The last thing you want to do is to send all 100 keystrokes that I happen to do within a very short time frame to my server. So we would start off by doing map and taking our inputs value. And then here we would debounce it, meaning by 500 ticks, we would stop for half a second, and then it would fire. But it would only fire when it is actually a distinct value, meaning if my keys go left and right and so forth, it's not going to fire. That's a really interesting thing to be able to do. And then what we can do is we can search, and this is probably the hardest thing for people to grasp. But the idea here is that we are doing a flat map. But what we're doing is the fact that a lot of these are going to be coming out at a given time. And the problem with asynchronous programming is the fact that things can come out of order. This Ajax request I made here could happen later and yet come back first, and it could totally screw up my results. And I see that all the time when I'm typing on my phone, and suddenly the wrong answer comes up just because it clobbered over the last one. And I only want the last one. So what this does is it physically cancels out all of the previous ones. Cool, huh? So then we can subscribe and bind it directly to the UI. So we kind of talked about the observable to be able to create it and so forth and call on next. And really we have this kind of grammar police, as it were, where you're only allowed to have non-overlapping values. They can end by on error or uncompleted, but you can't have overlapping things and you can't have things after completion. So if you abide by that, that's great. And just as well, how do you actually implement something that's particularly useful on top of an observable? Well, we have an eye chart, so you really don't have to. And this doesn't even cover all of them, but it comes close. So what we would do is we would actually create a new one. So remember, these are all immutable, just as an array, when you call array.map, it returns a new map. So in this particular case here, we're going to create a new observable based upon the existing observable by calling subscriber for each, getting the result from the selector call, catching an error if there's an error from your user code, and then calling on next with the results, and then on error and on completed as well. So basically, you're handling the entire life cycle of a particular operation, such as a map. Very, very simple and not much code. Of course, the real code's a little bit more complex than that, but that's the basic idea, is the fact that we're trying to break it down into something that's very, very easy to use and very easy to understand to create your own. Now let's talk about a little bit more complex kind of problem. So for example, we're on a hardware-constrained device, and I want to make sure that I have a responsive system, so only the things that are in my screen I want to be able to see. So what we can do is we can listen for the document scroll and to bounce out a little bit just so people can do like this and that, and it doesn't actually cause things to go horribly wrong. And then what we can do is decide whether the row is visible or not and make sure it's distinct and so forth. So we can filter out whether the row is visible or not. So we can start polling here in the background every 10 milliseconds, getting the row data until it hides. And when it hides, everything about that thing goes away. Like I said, all of these slides are available. You can take a look at all the code that you needed to beforehand. But in callback hell, as we had before, can easily be redone in such a way that we can say the initialize flat map to the play attempts, then authorize the movie, try 3 times, and then taking till the cancel. So it's even gone even further than the previous example because we actually have a way of hitting that cancel button and canceling the entire request. And then basically when we want to get the ticket, we can play, or the license, we can play the license or tell you you're out of luck. So, like I said, in terms of the burning yourself, there's a lot less chance of us, Rx being on the right and callbacks being on the left there. So Netflix has also created ideas of socket subjects, the idea that you can have failure call, a lot of failure handling and so forth. So they use this throughout a lot of their back-end infrastructure, and they happen to open source it, which is really awesome. Netflix OSS is really great about doing a lot of things out in the open, which is awesome. And once again, we can do simple things like finally and catch, just as you couldn't do with promises, but we can easily do by using catch, return some default data, and then do some cleanup if we want to. And yes, we can handle back pressure too. Now, what's really interesting is the fact that we are working with Netflix or working with others. In fact, we're actually shaping the future of a lot of these frameworks that you use on a daily basis. So, for example, in Angular 2.0, observables will be a first-class citizen. So people will be able to call, subscribe, and all of their data access points will be able to be observable. That's pretty cool. Ember, we have a project called Ember. It does some really nice stuff, and React, of course, we're trying to influence them as well. It's like I said, it's really super simple to use React and Rx together in terms of I can just create an interval every second, set the state, and then at the end I can turn off all of those particular things. So the schedulers, the last kind of secret sauce, is kind of the when, where, and how aspect. So we can say schedule some work, do it asynchronously, and basically cancellation. So cancellation goes right to the core of it, which makes testing completely easy. And it will also make it where you can change the context in which something is executed, whether it's executed on the as fast as possible or using request animation frame. So, when we're talking about async await, well, we already have that in terms of we have that through web generators, so you can retry, catch, and do finally, and console.log the results. And we're working as well on ES7 and getting the idea of async generators or observables directly into the runtime itself. You want to learn? There's a great resource there. That's pretty fascinating. RxMarble is also a pretty great way of visualizing all of those sorts of things. if you really want a detailed description of how you actually implement something fairly complex in terms of logic and not just games, the Sweet.js editor is written completely using Rx for all of their coordination stuff. So, I will leave you with one thing. If you can remember one word, I want that to be push.
Oh my God, that was rad. I think I can do it too. Push! 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 Dude, let me do one alone! Push!
That was good.
Wasn't that good?
So thank you. And like I said, Tali, if you want to check that out, the idea there, data privacy and so forth, I think it's a really, really cool idea that we're actually on the forefront of that. So we really believe in what Linda was talking about in terms of information freedom and so forth. So thank you all very much.
Do you want to join me for?
Oh, sure, why not?
Let's do that.
If I must. Wow, this is a
You
pretty
must.
funky color. It just changed colors.
I know, it's amazing, isn't it? It's magic couch.
That is awesome.
I thought that was you doing it with your like wizard powers.
Well, someone had asked whether all of my what colors my things happen, my stars happen to be. So, yeah, probably somewhere in that range.
So is that a big hat to fit your big brain?
No,
Because that was quite intense.
It is intimidating to some people, I'm sure, but at a certain point, I just wanted this to kind of serve as a reminder. I was an early open source advocate at Microsoft that, I helped Node get its funding to fund libuv development and so forth. So I've been a very big supporter. I got Rx open source in 2012. Worked on early F# open source. So I've been running the gamut, and everything that I do now is completely open source unless there's a physical reason not to. So everything we're doing with Tali Project, completely open source. Our mailing list, everything about it.
I think that's a great philosophy, and I'm really happy to see that happening across not just tiny corners of Microsoft, but more and more.
Yeah.
There was actually just one question from the audience, and I think it's an important question.
Okay.
Is it isomorphic?
Oh, good golly. Can people use Rx on the client and the server? Wow. Yes, in fact you can.
In fact, you can. So the question. It is isomorphic.
Yeah, absolutely.
Yeah.
Absolutely. What's that?
What
No.
happens when he says it? It sounds like a spell, and he's got his hat on, so I'm not sure that... Maybe something explodes, I don't know.
No. Yes, I've got this cone. Yeah, no.
Yeah, no, okay.
It's a dunce cone, really.
It really is the end of the day. There were no more questions, and to be honest, I don't think I can ask intelligent questions to your subject matter there. We do have a very small part of the program left, and if
anyone wants to yell anything at me, go for it. I'm more than welcome to. But actually, I did want to talk a little bit about Linda's talk previously, because that kind of struck me to the core as well. Is the fact that I, along with Chris Williams, who is the founder of JSConf, have done a lot of things such as DigiGirls, where we've gone to 6th to 8th grade girls and taught them a little bit about 3D printing, had them fly a drone and so forth. And he's kind of taken his business off and trying to fix education, which is awesome. We've also done events at schools and so forth for high school computer science as well. So it's something that strikes me as something that should be mandatory, because I was a kid. I'm privileged enough that I had a Commodore 64 when I was 7 years old, and I was sitting there and didn't know quite what to do with it. So my mom, who actually got me into computer science, just put this whole big set of books in front of me, because that's what people actually did, is they read books back then. And so I just started pouring through them, and I would find each line, and I would jiggle one of the numbers and see what happened to change. And when I see game programming, that's awesome. But I was just going off and trying to make whatever I want, and it didn't have to be a game. It could be art. It could be anything. And that's why I like to see kind of freedom of expression, whereas games seem fairly constrained in terms of what they do, versus focusing on the art aspect of what we call STEAM in America instead of STEM, where we actually add the arts component in there.
That's an interesting thought.
Is really important.
I agree. We are going to have to sort of stop our little chat there, because we do want to do one or two more things now. I think if I get the signals right from the red shirts here, my time is up. My microphone is going off.
Hello?